Right, we're going to have a look at the June 2015 non-calculator question 19. It's worth 6 marks in total. So there are n sweets in a bag, 6 of the sweets are orange, the rest are yellow. So I don't know how many are yellow, just the rest of them are. It says Hannah takes a sweet at random from the bag, she eats it. So that means it's without replacement, she's not putting it back into the bag. She then takes at random another sweet, she eats that one. The probability she eats 2 orange sweets is a third, and for part A we have to show that basically. Well, how I decided to do this question is, what do I know? Well, I know there's 6 orange sweets, and that if she eats 2 orange sweets, the probability of that happening is a third. So I use that. Now, this is a probability and an algebra question combined together. So, I've summarised my information there. I thought of it as a tree diagram in my head, and I said, well, that's her first pick. She's got the choice of orange and yellow. Don't know how many yellow sweets that she's got, but doesn't really matter. I know that there's 6 orange out of a total of n. Again, doesn't matter that I don't know what n is. So I said, okay, she's definitely taken orange one. Her second pick, again, she's got 2 choices, orange or yellow. If she's taken 1 orange one at the beginning, that leaves her 5 orange, and also leaves her 1 less in the bag of sweets as well. So it's 5 oranges left out of n minus 1. And when we're going across the tree diagram, we multiply. So I know the probability of 2 oranges in a row, so she eats 2 orange sweets, is a third. So I said, well, if I'm multiplying going across my tree diagram, and it's equal to a third, I can set up my fractions and my calculations. So this is what I did. I did 6n times 5 over n minus 1 equals a third there. And that's what I ended up with. And then with your fractions, multiply your tops together, multiply your denominators together. So I've got 6 times 5 is 30. And I've expanded the bottom as well. So I've got n squared minus n. So I've got this is equal to a third. Now, I obviously need to get rid of the denominator there and the denominator here, so I've just brought this over to this side and brought the 3 over to that side there, just cross multiplied, and that's given me 30. And then I'm just showing you, just in case that was another number, I know it's 1, it's nice and easy, but if that was 2, for example, that you'd have to do 2 times everything in your bracket or from your denominator over there. So I expanded out my brackets, and then all I've simply done is made it look like what they wanted me to, so I've just taken everything over to one side, and as you can see, I've proved the first part, which was show that n squared minus n minus 90 equals 0. So that's just there. Part B asked us for 3 marks to solve the equation and to find the value of n. So for that, I homed in on the word value. It doesn't say values, it's value, so it's singular. So there's only one possible answer here. So first of all, I looked here and I tried to factorise it. It's a non-calculator paper, so I don't really want to use a quadratic formula, but you can if you want to. So I've just listed out my factors. That multiplied to give me -9. So I went with -9 and 10, -10 and 9. I know there's others, but I figured out it's those 2 because they obviously have to add to give me the negative n in the middle, the -1 in the middle there. And the only, well, -9 and 10 didn't work because although it gives me -90, it doesn't give me the negative n in the middle. But -10 times 9 gives me the -90, and -10 add 9 would give me the negative n or the -1 that I'm looking for. So I've come to factorise it. N plus 1, n minus 1 equals 0. I've taken the first bit, made that equal to 0. I get n equals -9. That's not possible because we're looking at sweets. How could you have -9 sweets? So that's off the list. So therefore, just quickly check in, take my second bracket, equal that to 0 as well. I get n is equal to 10. That makes more sense. So therefore, there must be 10 sweets to start with in order to have a probability of a third of picking 2 oranges.